All right, hi everybody. Welcome to this set of notes on writing and balancing chemical reactions. It shouldn't take too long. There's not a lot to write down. You need to use your brain while we're working, but you won't have to write a whole lot. All right, so first of all, just a quick review, signs of a chemical reaction. These are things we covered way back in our first unit. If a reaction is giving off heat or light, if a gas is forming, if we form a precipitate, remember that's like a solid that forms in a liquid reaction, or if we see a color change, those are all indicators of a chemical reaction. We've seen that before. So how do we write out a chemical reaction? And that's what we're going to look at tonight. So first of all, you have to understand something called the law of conservation of mass. You need to know this. How much you need to write is your decision, but you need to understand the basic concept of it. So it says mass is neither created nor destroyed in a chemical reaction. The total mass stays the same. The only thing that can happen is that the atoms can be rearranged. So take a look at let me see if I can move my image here a little bit. Take a look at the image down below and look at the methane plus the oxygen makes carbon dioxide and water. Notice the methane, it has one large carbon atom and it's surrounded by 4 white hydrogen atoms. If you look on the other side of the arrow, do you see the one large carbon atom and then the 4 white hydrogens attached to the water? And then on the left side, we've got 4 red oxygen atoms, and all 4 red oxygen atoms are present on the right side of the arrow. Did I say left side? Anyway, if you also look at the mass is the same. So on the left side, it's 16 grams plus 64 grams, the 2 times 32. That equals the 44 grams plus the 2 times 18, which is 36. Those two sides have to add up to be the same. That's law of conservation of mass. We kind of saw that a little bit earlier in the year before, but we're also, we're kind of building on that now. So when we write a chemical equation, you need to have the reactants and you need to have the products, and you need to know the difference. And sometimes students get mixed up. It's very simple if you pause for a second. Products are what are produced. So they come at the end of the equation after the arrow. What is reacting is what you have before the arrow. So the A plus B, those are the reactants, and the C plus D, those are the products. If you can't keep that straight, you need to write that down. All right, so now there's a few other symbols. I don't know that there's a whole lot you need to write here. The arrow simply means what's being produced. That's what's, you're watching the direction of the reaction. Actually, and sometimes the arrows can point the opposite direction, or sometimes you can have arrows that point both directions because some reactions can go backwards, forwards, or both directions. The plus just means you're adding them together. But then sometimes in parentheses, you'll have the state of matter. So it could be a solid, a liquid, a gas, or aqueous. Maybe the only one you don't know is aqueous. And that's when we have a solid that's dissolved in water. That's different than the liquid. So for example, we have liquid mercury. That has nothing to do with water. There's no water involved in it. It's just mercury that's in its liquid state. Whereas an aqueous solution, you might have salt water, for example. And so that would be salt dissolved in water, and that would be in the aqueous state. So that's maybe the only one that you're not familiar with. Okay, writing equations. I don't know that you need to write anything down. Just listen and see if we can figure this out. So it says identify the substances involved. So in this equation here, we've got some hydrogen, we've got some oxygen, and we're making some water. Use symbols to show how many of the atoms you have. And now we're going to introduce you to a term that you do need to know. It's a new term, but I'm not sure you need to write it down again. If you can just use your brain, then you're probably pretty good. The term is the word coefficient. A coefficient, unlike a subscript, the subscripts are the little numbers written down below. Superscripts are the high numbers that are the small high numbers that are up above, but this is a coefficient that is the large number in front. That might be confusing. So the large number written in front. So notice in this equation here, there's a 2 in front of the H2. There's nothing in front of the O2. That's an implied 1. You've seen that before in chemistry. We often don't write the number 1 or say the word 1, like mono. We don't say it very often. And then there's a coefficient 2 in front of the water, the H2O. So that's the coefficient. You need to know coefficients. That's what we're going to use to be balancing our equations, is using those coefficients. And then finally, it just gives you, I shouldn't say finally, but again, it gives you a reminder about diatomic elements, and that's going to come up again in a minute. The diatomic elements, remember the phrase hunkel fiberi, hunkel fiberi. Anyway, they also make the diatomic molecules. You've written them down before. They make the number 7 on your periodic table plus hydrogen in the corner. So the number 7 plus hydrogen. The diatomic molecules are always partnered with each other. So if you have chlorine all by itself, it's never ever just Cl. It's always Cl2. Fluorine is always F2. Hydrogen is always H2. So when you're writing these equations, you can't forget that. So take a look at the equation that we have in the upper right-hand corner here. If I were to say the words, it would be hydrogen plus oxygen makes the product water. However, you need to remember when you write the equation that hydrogen isn't just H, it's H2. And oxygen isn't just O, it's O2 when it's by itself. Now, to be clear, look at what the O looks like in water. But that's because oxygen isn't by itself. It's with something else. So when it's with something else, it could be a single oxygen. It doesn't have to be 2 oxygens. We're only talking diatomic when it's not combined with anything else. Then it has to be diatomic. Okay. Moving on. So then we write out the chemical formula, and then we also need to state the state of matter. Is it a gas? Is it a liquid? Is it a solid? Precipitates are usually solids that are coming out in the liquid itself. Okay, so let's try a couple equations. It says chemical reactions always conserve mass. The mass of the reactants equals the mass of the product. Again, atoms can't be created or destroyed. They are only rearranged. So the equations have to be balanced in order to support the conservation of mass. So here's how we do it. Once an equation is written with formulas, so the previous equation, we saw hydrogen as H2, and we saw oxygen as O2, and then it makes H2O. So that's it written in formulas. Then we can use coefficients in front of the chemicals to make sure that we have balanced amounts on the left and on the right. But what's super important is we are not allowed to ever change the subscripts. So we can't go from H2 and suddenly make it H3. That's not allowed. You can only change the coefficient that's in front, not the little subscript at the bottom. So it says here, get my picture out of the way again. H2O is definitely not the same as H2O2. And so you're never allowed to mess. So H2O is water, H2O2 is hydrogen peroxide. Okay, so here's some hints for balancing equations. Right now, they're going to go over your head because you've never balanced an equation, but these are tips that later on might be meaningful to you. So first of all, always use a pencil. Many, many, many times you will end up erasing and trying it again. And I do that all the time as well. So, don't feel bad if you're erasing a lot. Watch for the diatomic elements. So if it says iodine plus bromine makes something else, make sure it's I2 plus Br2. So don't forget your diatomic elements. Watch for polyatomic ions. Remember, on our periodic table, we have them on the back of our periodic table. Watch for them. If you see phosphate and there are 3 phosphates on the left, there's a good chance that you can balance that with 3 phosphates on the right. So pay attention to your diatomic molecules. Another tip is that water, H2O, can also be written as HOH. Do you see that? Do you see that there's 1 O and 2 H's if I write it HOH? If you have the polyatomic ion hydroxide, OH, you might be able to balance it with H2O by looking at how many OHs you have on the left and how many OHs you have on the right. If you have an odd number of atoms and you need an even number of atoms, multiply it by 2. That will often help you out if you have an odd number of atoms. And then finally, if you just have a single element like copper all by itself, balance that at the very end. Don't try to balance that at the beginning. Wait till the very end. Save also hydrogen and oxygen for the end when you're balancing. Balance other things first and then do the hydrogens and the oxygen. They're often kind of tricky. Okay, so it says the number of each element needs to be the same on both sides. So let's practice a few problems. So let's start right here. Actually, I have the answers on the next slide, so let me put these up here. You should pause the slide and then you can, or pause the video, and then you can try to work out these problems. I'm going to go ahead and do them on the next slide. No, I won't. I'm going to do them right in front of you. Hold on. Let's see if I can back it up. Let's see if I can back it up. There we go. Okay. So what do I see here? Water. I see H2 and plus O2 makes water. Well, we've already seen that on a previous slide, but let's mess with it for a second. I see there are 2 H's on the left and there's 2 O's on the left. But on the right, there's 2 H's and only 1 O. Well, that O is an odd number, so I think I'm going to put a 2 in front of the H2O. So if I put a 2 right here, that would mean I'd have 4 H's and 2 O's. Do you see that? It means I have 2. If I put a big 2 in front, it means I have 2 H2O's. So that means I would have 4 H's and 2 O's. Well, now the O's would be balanced. If I have 2 O's, they're done. But now I only have 2 H's on this side. So if I throw a 2 in front, then I would have 4 H's on the left and 4 H's on the right. So then it would be balanced. Let's take a look at the next one. I have N2 and H2, diatomic elements again. But on the right, I have only 1 N and I have 3 hydrogens. How could I balance that? Well, let's try balancing the nitrogens. And again, try, erase, try again. What if we threw a 2 in front of this NH3? So if I had 2 NH3s, then that would mean I'd have 2 nitrogens. Well, that's how many I have on the other side. Hey, that actually works. But now I would have how many hydrogens? If I have 2 NH3s, then that would mean I'd have 6 hydrogens. That's too many for over here. But what if I put a 3 in front of that one? Then I would have 6 hydrogens. I balanced it. Let's try the next one. Okay, zinc is a standalone, so let's try to balance that one last. We've got HCl, hydrochloric acid. We've got ZnCl2. Ooh, I see 1 Cl on the left and 2 on the right. I also see 2 hydrogens over here. Well, what if I just did the very simple thing of putting a 2 in front of the HCl? That would give me 2 hydrogens and 2 chlorines. And now I think the whole thing's balanced. I have 1 zinc on the left and 1 zinc on the right. All done. Easy sneezy. If you're confused about any of these, the answers are on the next slide. Okay, so then the last one is iron plus H2SO4, which is sulfuric acid, makes Fe2SO4. Oh my gosh, that's terrifying. How can I ever balance that? Well, it's not nearly as scary as you might think if you pay attention to the polyatomic ion. You have a polyatomic ion right here, the SO4, that's sulfate. How many sulfates do you have on the left, and how many sulfates do you have on the right? Well, on the left, we just have 1 SO4, just one of them. But on the right, we have 3 SO4s. Let's try messing around with that. Let's put a 3 over here. So now we would have 3 SO4s, but we'd also have 3 times H2, so we'd have 6 H's. So let's put a 3 over here. So we have 6 H's here. Then the last thing is how many Fe's we have. We have 2 Fe's here. If we just put a 2 there, bing, 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 all done. There are the answers in case you're having any questions about it. All right, let's try it again. Feel free to pause this video and try these problems on your own. I will do them on the next slide, and I can't remember if they pop up one at a time or if they're, yep, the answers are just there. Okay, so let me just walk you through it really quickly. I'm looking for my polyatomic ions in this one. It looks really intimidating to balance, but I see this polyatomic ion, NO3 nitrate. I have two of them on the right, but I only have one of them, just one nitrate on the left. So I think I'm going to put a 2 right here. If I put a 2 right there, that means I have 2 sodiums on the left. Oh, and look at 2 sodiums on the right. I have one lead and one oxygen. Oh, I think that's balanced. Let's double check. Sure enough. All right, let's take a look at the next one. Here's another polyatomic ion, carbonate. I have 3 of them on the right, and I only have one of them on the left. So what if we put a 3 here? Whoops, now what did I do to the silvers? I just made 6 silvers, so I better put a 6 over here. That makes 6 iodines. Uh-oh, how do I get 6 iodines? I only have 3 right there. Well, what if I put a 2 in front? Now I have 6 iodines, but I have 2 irons. Oh, look at that. I have 2 irons on the right side. Oh, sure enough, 6, 1. So whenever it's left blank, that means it's a 1. We're not writing the ones. So 6, 1, 2, 3 on that one. All right, I'll do maybe 1 or 2 more and then we'll move on. So C2H4O2, that's not a really clear polyatomic ion there. So what if we just try balancing the C's? I'm guessing here. So what if we put a 2 right here? What does that do? So that gives me the same number of C's on both sides. How many O's do I have? If I put a 2 here, I'll have 4 O's, 5 O's. Well, that's not very good because I have 2, 4 O's on the left side. It's always hard when you have an odd number to make it match on the right side. So I'm going to say let's just try to put a 2 right here. So now I would have, oh, look at that, 4 hydrogens if I did that, and 2 oxygens. If we go over here, let's add up all of the oxygens. If I have a 2 here, that's 4 oxygens. And if I have a 2 here, that's 5, 6 oxygens. If I just put a 3 there, then we would have, oh, row, I didn't do that right. What did I do wrong? It's hard to do it without actually writing it down. So give me a second. Oh, I know. I'm sorry. I missed that there were oxygens right here. So that's why I thought I needed to put a 3 there to have 6 oxygens. There's 2 oxygens right there. So I only needed the 2 right there. I'm going to move on quick. If we look at the next one, we didn't need to do anything. It's already balanced. 1 zinc, 1 carbonate, 2 lithiums, and 1 sulfate, and 1 sulfate. Already balanced. Love those. And then the last one, I see on the right that I have 5 sulfurs. So that's why I put a 5 in front of this one. But now that made me have 5 calciums. So I had to put a 5 over this one. And then all balanced. Okay, so just really quickly, it does get a little bit more complicated than just balancing them. Sometimes we're going to give you sort of a story problem where you have to write out the equation yourself. So this is what this story problem says. 2 atoms of aluminum, so that's just Al, react with 3 units of aqueous copper 2 chloride. Well, copper 2 is copper with a +2, and chlorine is a -1. Cross the charges. So that'll be CuCl2, and then Aq for aqueous. Produce 3 atoms of copper, a 3 in front, and 2 units of aqueous aluminum chloride. All right, aluminum is a +3 and chlorine is a -1. Cross the charges, so that's AlCl3. So we need to balance the whole equation, and we have to write aqueous and whatever. So here's what it would look like. This is the equation. Al plus CuCl2 produces copper plus aluminum chloride. But it's not balanced right now because we have 3 chlorines on this side and just 2 on this side. So we're going to need to balance the equation. I see, when I see a 3 and a 2, I usually reverse those numbers to make them 6. So I would probably put a 3 right here and a 2 over here, and that would allow us to have 6 of the chlorines. And if we do that, that is how you would balance that equation. Everybody, that's it. Let me know if you have any questions, and good luck balancing your equations.